Okay, so we're going to go over now just doing some practice with factoring with greatest common factor and with dots. So sometimes when we do this, we're going to actually have to end up doing both. We're going to have to end up doing GCF factoring, and then we'll also have to do dots. So let's just first go over what we know at this point. So right now, the two types of factoring we've done are GCF and dots. Okay, so we're going to look at these two examples now just to kind of refresh what we mean when we say these types of factoring. So what kind of factoring can be used with the expression 225 minus x squared? Explain your answer and then factor completely. So if you look at the 225 minus x squared, okay, you'll notice that the operation in the middle is subtraction, and both terms, the 225 and the x squared, are both perfect squares. So this is going to be dots, difference of two squares. So the first thing we're going to do is to write down our square roots of each piece. So the square root of 225 is 15, and the square root of x squared is x. Okay, now when we want to actually do the factoring for dots, it's always the same procedure. We do a double bubble. Now in this case, because the 225 was the first part, that means I'm going to put the 15 in the front of each bubble. Okay, and then since the x squared was the second part, I'm going to put the x in the back of each bubble. And then when it comes to the signs, it's always going to be that one of them is plus and one of them is minus. It doesn't matter which way you do it. So you could have done minus and then plus, and it still would have been the same. It still would have been correct. Okay? So that first one right there, that was dots. So now let's take a look at number 3. What kind of factoring can be used with the expression 24x squared minus 54? Explain your answer and then factor completely. So if you look here, we do have the x squared the way we had in the previous problem, but if you look at the 24 and the 54, neither one of those are perfect squares. So we actually always want to first check to see, do we have a greatest common factor? So right now I'm going to list my factors of 24, and I'm going to list my factors of 54. Now, just as a little reminder, you can get your factors of a number by going into your calculator, and you can use the calculator I sent you the link for online. You would hit the y equals, and then in your y1, so if you want the factors of 24, you would type in 24 divided by x. Then you would hit second graph and go into the table. And starting at 1 on the table, it would list the factors for you. You would only write down the whole numbers. You would not write down any decimals. So our factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay? Our factors of 54 are 1 and 54, 2 and 27, 3 and 18, and 6 and 9. Okay? So now I'm going to go ahead and just circle the numbers that both lists have. So both lists have 1, both lists have 2, both lists have 3, and both lists have 6. Okay? So those are all common factors, but the greatest common factor, the biggest of all of those numbers, is 6. So our GCF is 6. Okay? Now, we wouldn't have an x or a variable being a part of the GCF because we only have the variable in the first term of the expression, the 24x squared. We don't have it with the 54. So since it's only with the one term, it's not going to be a part of our GCF. All right, so now once we found the GCF, we are going to, let's rewrite the original problem. And we are going to divide each of these pieces by our GCF, which is 6. So when you're factoring out a GCF, what you're actually doing is dividing it out, okay? Now, once we do that, we end up, let's pick a different color. We end up with, so 24 divided by 6 is 4, and we still have the x squared. And then minus, now 54 divided by 6 is 9. But remember, we still have the 6 on the outside. It didn't disappear, it just stepped outside of the problem, okay? Now, looking at what we have left. Now, normally, from what we were doing last week, at this point, you would stop. You'd be like, all right, I'm done with the problem. But now, let's look a little bit more closely. So if you look at what is inside our bubble here, take a look at each term. So if we look at the 4x squared, what I want you to be able to see is that 4x squared is actually a perfect square, okay? Same thing with 9. 9 is also a perfect square. So we're actually not done here. We can actually keep going. So we started with GCF factoring, and now we're going to do dots, okay? So I'm going to take the square root of 4x squared, which gives me 2x, and the square root of 9 gives me 3. I'm going to do it, I'll write it down here. So this part then, just in the bubble, turns into this. So the 2x goes in the front of each bubble, the 3 goes in the back of each bubble, 1 plus and 1 minus. And we also can't forget that the 6 is still there. The 6 didn't go anywhere. The 6 is still hanging out on the outside. So this whole thing right here, that is our final answer. That is it factored completely. So it's doing 2 steps in order to finish factoring the problem, okay? So now what I wrote down here on the bottom of the first page is that when you are factoring, you always check for a GCF first, and then you can look for dots, okay? So GCF is always going to come first. All right, so now let's take a look at some examples, okay? So for each one of these, we are going to be factoring completely, okay? So for number 1, we've got 9x squared minus 9. So the first thing we want to think about is, do we have a GCF? So this one's actually kind of easy to see because both of them have 9. So the greatest common factor is 9, okay? So I'm going to go back to my original problem, and we're going to divide each one of our pieces by 9, okay? So when we do that, now 9 divided by 9, I know that a lot of times we say cancels out, but really what's happening is it's reducing to 1, but you don't need to write. You can just leave the x squared, minus, now 9 divided by 9, it doesn't just disappear, it becomes 1, okay? And remember that the 9 did not just disappear, it just stepped outside, okay? So it's still there. All right, now let's look at what we have on the inside, and let's see if we can figure out if we can factor this even further. So difference of 2 squares. Well, inside here I have a minus sign. X squared is a perfect square, and 1 is a perfect square because 1 times 1 is just 1. So the square root of x squared is equal to x, and the square root of 1 is equal to 1. So now this part turns into, we do our double bubble, x is in the front of each bubble because the x squared came first, 1's in the back, 1 plus and 1 minus. And don't forget, super important, bring this 9 over here, okay? So this is your final answer, okay? All right, so it's just had to go through the process 2 times, okay? All right, let's look at number 2. So for number 2, we're going to start off the same way with checking for the greatest common factor. So we've got 64 minus 4x squared. So let's list our factors of 64. So our factors of 64 are 1 and 64, 2 and 32, 4 and 16, 8 and 8. Okay? And our factors of 4 are 1 and 4, and 2 and 2. So let's circle the factors that we have in common. We both have 1s. We've got the 2, which actually in the second one appears twice, and then we have the 4. So the biggest number that we have, that the greatest of all the common factors, is 4. So we're going to take that GCF of 4 and we're going to go back to the original problem, divide each term by the GCF. So 64 divided by 4 is 16. And then 4 divided by 4 just simplifies to 1. So it's 1x squared, or you can just write x squared. And then don't forget, you still have to put the 4 on the outside. It didn't disappear, it just stepped outside. Okay. And now let's look carefully at what we have remaining on the inside. So on the inside, we have 16 minus x squared. So now you want to ask yourself the question, can I factor this even further? So we're dealing with subtraction again. We know that x squared is a perfect square, and we know that 16 is a perfect square because 4 times 4 is 16. So we are going to keep going. This is going to be able to be factored even further. So the square root of 16 is 4, and the square root of x squared is x. Okay, so now down here we're going to do our double bubble, and we have 4 plus x, 4 minus x. Okay, the 4's went in the front because the 16 was in the front, and the x is in the back, and then the plus and minus, and then just don't forget, you need to also bring down the 4 that we had in the beginning that was originally factored out by GCF. Okay? All right. Let's keep going. Let's take a look at question number 3. So, x to the 4th minus 9x squared. Okay. So, keep in mind that the x to the 4th has an invisible 1 in front of it, but when we have it like this, there's not going to be a number as part of our GCF. Well, the GCF, the number would be 1, but we don't really care about that. So let's focus on the variables. So we have x to the 4th and x squared. So that's something that is common, the fact that they both have the x's. So if you remember from last week, when we are taking the GCF when it comes to variables, we always take the lower exponent. Okay, so our GCF then in this case is going to be x squared. Okay, so I'm going to go back to my original problem and divide each of my pieces by x squared. Now recall that when we divide variables, we subtract our exponents. So x to the 4th divided by x squared, we just do 4 minus 2 and we get x squared minus. Now with the 9x squared over x squared, the x squared is reduced to 1 and you're just left with 9. So x squared minus 9, but don't forget to put your parentheses. Okay? You still had the x squared on the outside. All right? Now you want to take a minute and look at what you have and ask yourself, can we go even further? So we're dealing with subtraction, which is difference. We know that x squared is a perfect square, and we know that 9 is a perfect square. So the square root of x squared is x, and the square root of 9 is 3. Okay? So now we're going to factor this part here. We do our double bubble. So we put x's in the front of each bubble and 3's in the back of each bubble. 1 plus and 1 minus. And our last thing is just to remember that that x squared was still there. Didn't go anywhere. So we have to bring that down and keep that on the outside. Okay? All right. So one more in this packet, and then you'll be able to do some of the practice on your own, which is posted on Google Classroom. All right, so we always check first for a GCF. So let's look at our 8 and our 18. Let's list our factors. So our factors of 8 are 1 and 8 and 2 and 4. And our factors of 18 are 1 and 18, 2 and 9, 3 and 6. Okay. So now let's circle whoever we have in common. Okay, so just the 1s and the 2s. So then the largest, the biggest of the greatest of the factors is 2. So our greatest common factor is 2. Now let's go back and just look, because both of these terms, one of them has an x squared, one of them has a y squared. Now, even though they both have variables, they're not like variables. Okay, so neither variable is going to be a part of the GCF. So it's just going to be the number, because x and y are not common factors. They're different terms. So let's go back and divide each piece by 2. So 8 divided by 2 is 4. And then we still have that x squared minus 18 divided by 2 is 9. And then we still have the y squared. Okay, so put that in parentheses and put your 2 on the outside. All right. And now this is the point when you sit back and ask yourself, okay, can I keep going? So if you look at it carefully, it's difference because it's subtraction. Now the square root of 4x squared is 2x. And the square root of 9y squared is 3y. Okay? So then for this part here, I'm going to go down and do our double bubble. So the 2x is going to go in the front because the 4x was in the front. And then the 3y will go in the back because the 9y squared was in the back. 1 plus and 1 minus. And lastly, just do not forget, please, to bring down the 2 from the beginning, because that is still a part of the problem. So this right here is your final answer. Okay? So this is up on Google Classroom along with the answer key is all written out. And there is an assignment up that goes over this stuff. So hopefully you will be looking this over. And if you have any questions, email me, send me a remind, come to one of my Zoom sessions, and we will get it worked out. Thank you.